Welcome back to The Explainer. Today, we're diving into the Day 4 and Day 5 lessons. And honestly, we're looking at a genuinely sneaky concept in web hacking, the Open Redirect. I'm super excited to guide you through this because we're going to learn exactly how attackers take completely trusted, highly reputable domain names and twist them into dangerous traps. We're drawing directly from Peter Yaworski's awesome real-world bug hunting field guide, looking at actual bounties paid out by major companies. So grab your notes. This is where theory meets practice.
Okay, let's dive into this. Here is our roadmap. First, the illusion of trust. Second, the mechanics of open redirects. Then, we'll apply this by looking at hacking Shopify with URL parameters, check out a HackerOne DOM exploit, and wrap up with a review of key takeaways for your own hunts.
All right, part 1, the illusion of trust and how trusted domains become traps. So how exactly does a domain you completely trust get turned into a trap? Think about it. If you see a link starting with google.com or shopify.com, your brain just instantly registers it as safe, right? But what if that trust is actually just a gateway? The whole danger of an open redirect is that it hijacks a legitimate site's good reputation. Attackers use that trusted starting point to launch phishing campaigns or distribute malware. They're basically tricking users who think they're on a safe domain, when in reality they're being silently handed off to an attacker's server behind the scenes. Which brings us to the formal definition. An open redirect happens when a developer inherently trusts attacker-controlled input, allowing it to bounce a user to another site. Now, you might have heard that organizations like OWASP drop this from their top 10, or that Google's bug bounty program sometimes treats these as too low impact to reward. But please, do not let that fool you. Getting a solid grip on open redirects is absolutely crucial. It teaches you exactly how browsers handle routing, parameters, and trust. And you know what? That knowledge is the fundamental building block for way more complex exploits down the road. Moving on to Section 2. Let's break down the mechanics and vectors of open redirects. When you are hunting, you need to be glued to your proxy history, whether that's Burp Suite, Zap, whatever you use, and keep an eye out for these common HTTP GET request parameters. These are literally your red flags. See, developers intentionally build redirect functionality into sites, and they usually pass the destination right there in a parameter. Sometimes it's super obvious, like redirect_2 equals or next equals, but other times it's minified down to just a single letter, like R equals or U equals. If you spot any of these on your target, you instantly know where to start poking around. Now, let's contrast how these redirects actually fire off in the wild. On the server side, a parameter-based redirect usually triggers an HTTP 302 status code. The server basically bounces you to a new URL using the location header. But on the client side, attackers can use an HTML meta tag refresh. The absolute key part of that meta tag is where it says content equals 0. That 0 tells the browser to wait literally 0 seconds before making a GET request to the attacker's URL. It is instantaneous. Now, what's really interesting about this slide is our third mechanism, the DOM window.location property. As you know, the document object model lets JavaScript dynamically manipulate a web page. If an attacker manages to inject this single line of JavaScript into a page, the browser immediately interprets it and forces the window to load the attacker's URL. There's no server headers needed, no HTML tags. It is just pure JavaScript taking the wheel. All right, Section 3. Let's look at some case studies right from the field, starting with hacking Shopify using URL parameters. This is such a great real-world exploit. So Shopify is obviously a massive commerce platform, and they let store admins customize their themes. As a part of that workflow, Shopify built a feature to preview these themes. How does it work? By redirecting the store owner to a specific URL right after they hit preview. Let's deconstruct this one. An attacker noticed the URL had a parameter sitting right at the very end, domain name equals. The system expected this to be the user's Shopify store domain, and it was designed to automatically append /admin to whatever was in that parameter. But here's the catch. Shopify wasn't actually validating that the input was a legitimate Shopify domain. So by simply changing that value to attacker.com, the hacker created a highly trusted Shopify link. When clicked, it immediately bounced the victim right off the platform to attacker.com/admin. It's just simple, elegant, and super effective. And this brilliantly illustrates our next point, which is a second Shopify login bug that requires a slightly more creative bypass. It shows exactly how DNS can work against developers. In this case, Shopify used a checkout URL parameter, but the code was hard-coded to tack the parameter's value onto the end of a Shopify subdomain. The attacker couldn't just drop in a full, shiny new URL. Instead, they added just a single special character, a period. By entering period.attacker.com, the resulting URL became myshopify.com.attacker.com. And because DNS lookups resolved from right to left, the rightmost domain label was now attacker.com. They effectively stole the routing right out from under Shopify's nose. Moving into Section 4, the HackerOne DOM exploit, and bypassing the interstitial warning. So HackerOne tried to be smart here. They implemented these interstitial warning pages. You know those pop-ups that warn you, hey, you're leaving our site, is this safe? But they made one crucial exception. They used Zendesk for their support portal, so any link pointing to a HackerOne Zendesk session bypassed that warning entirely. Well, a hacker named Mohammed Jamal realized that literally anyone could create a custom Zendesk account and manipulate its theme. Jamal dropped a DOM window.location payload straight into his custom Zendesk header. So here's how it plays out. A victim clicks a trusted HackerOne link. HackerOne skips the warning because it points to Zendesk. And then Jamal's Zendesk page instantly executes the JavaScript, firing the victim off to evil.com. Boom, another $500 bounty secured. I really want to pause on this quote from Peter Jaworski for a second. When Jamal first figured out that the interstitial warning was missing on Zendesk links, Zendesk actually ignored his report. They genuinely didn't think it was a real vulnerability. But Jamal didn't just give up, he persisted, he dug deeper, and he built that exact JavaScript exploit to definitively prove the impact. That persistence, that is what forced the fix and actually earned him the bounty from HackerOne. Finally, Section 5, key takeaways for hunters to help build your bug bounty arsenal. So the crucial point is how you actually apply this in the wild. First, rigorously check your parameters. You need to actively monitor your proxy traffic for absolutely anything that looks like a routing command. Second, practice filter bypassing. If an application hard codes part of a URL, throw special characters at it. Try a period, try an @ symbol, and see if you can break their DNS logic. And third, look for integration abuse. Map out exactly what third-party services your target trusts, stuff like Zendesk or external analytics, because those trusted pathways are very often the secret backdoor to bypassing security warnings entirely. I want to leave you with this thought. What hidden trust is your target site exploiting right now? Every single web app relies on trust. It trusts its parameters, its DNS lookups, its third-party tools. Your job as a hunter is to find exactly where that trust is blind. Take these techniques, scour your proxy logs, and see where you can force a trusted domain to behave badly. Happy hunting, and I'll catch you in the next explainer.